Before moving on to the next lesson, please try this warm-up question. In each case, does the situation represent one or two variable statistics? So here's the first situation. We have truck weight and mileage. In the second situation, we have heights of black cherry trees, frequency, and the different heights. So for each of these, is it one variable or two variables? Pause the video, try to figure it out, and when you're done, check back in to see how you do. So truck weight is an attribute that I can measure. I can measure the weight of a truck. I can also measure the mileage of that truck. So if I can measure two attributes of the same item, this is two variable data. Over here, I have heights. Well, I can measure height. That's an attribute I can measure. So that's one variable. Frequency is the number of times something occurs. That's not an attribute or a characteristic that I'm measuring. Frequency is not a variable. So there's only one variable in this set of data. So this next lesson in our data management section is called Relationships in Scatter Plots. So we're going to spend a lot of time looking at scatter plots in this lesson, and our goal is simple. We're trying to interpret graphs to describe a relationship. So remember, when I make a scatter plot, I have two variables, and I can look at the relationship between those two variables. Example 1, create a scatter plot of the following data. Okay, I've got truck weight in pounds and mileage in miles per gallon. This is two variable data, so I need to put the two variables on my two axes. Now the tricky part that, well, most people find it tricky is where do you put each variable? Because it kind of matters. The horizontal axis, or the x-axis, this is called our independent variable, and the other one is our dependent variable. Independent means it doesn't depend on anything, whereas dependent is the opposite. So we have to decide, okay, is it the weight or the mileage that depends on the other thing? So think of it like this. Does the weight of a truck depend on how much fuel it uses when it drives? Or does the amount of fuel that gets used during driving depend on how heavy the truck is? I would say the second thing I said is probably true. It's the mileage depends on how heavy the truck is and not the other way around. So if mileage depends on the weight, mileage is dependent. That's going to go on our y-axis. The weight of the truck is independent. It doesn't depend on how much fuel gets used when it drives. So it's independent. It goes on the x-axis. So once you've decided which variable goes where, you just need to set up your axes. Get a nice scale. For the weight, we're starting over 3,000 pounds. So it doesn't really make sense for us to start our scale at 0 and then go up by hundreds or whatever, because all our data points would then be over here on the graph. When you're making a scatter plot, you want to make sure your points are plotted in such a way that they take up most of the space on your grid. So I'm going to skip a few. I'm going to start at 3,000. And when you skip a few, you got to draw the special zigzag looking piece. It's called a broken axis. It's just signifying that you're not starting at 0. And same with mileage. I don't have to start at 0 for mileage because the lowest mileage on the chart is 15. So again, if I started at 0 and went up by 1s or 2s, all of my data points would be squished up to the top part of the graph. But if I want to spread it out more, I'm going to have another broken axis down here. And just make sure your scale goes up by an even amount each time. So you're going up the same amount of spaces for the same amount of units. And then when you're plotting your points, you just have to find the point where, for example here, when the weight is 5,440, the mileage is 15.5. That's going to be over here. And when you plot your other points, it should look like this. So let's look at this scatter plot. We can see as the weight of the truck increases, it looks like overall the mileage decreases. So let's go to example 2, but keep this image in the front of your mind because we're going to be talking about it. Okay, so using that graph from example 1, and just a reminder, it looked something like this, where we had weight going along the independent axis and the dependent variable was mileage in miles per gallon. We saw that the dots kind of went in this direction. Okay, so is there a relationship between weight and mileage? If so, describe the relationship. Okay, so if you're describing a relationship between variables, you have to look at, is there a trend overall? Well, it looks like the points are, in general, going downwards when we read it from left to right. So we would say, as the weight of the truck increases, the mileage decreases. As the weight of the truck increases, the mileage decreases. So anytime you're asked to describe a relationship, you want to word it like this. As the independent variable increases, what happens to the dependent variable? Does it increase, decrease, or stay constant? Now, sometimes you might not see a relationship. Let's say the points were scattered all over the place and there wasn't a clear trend that it was decreasing or increasing or anything like that. Then you would just say there's no relationship. Okay, back to our question here. Which two trucks have approximately the same weight? Okay, well, let's look back at our table of values. And we can see that this truck has a weight of 4,530. This truck has a weight of 4,560. So they're really close in weight, but look at their mileage. That one's 17, that one's 15. So they're quite different. Their mileage is not close at all. So that begs the question, why might two trucks with the same weight have different mileage? So this isn't a math question per se, it's more thinking behind the numbers, what might cause these two trucks with very close weights to have such different mileage. So take a minute to think about it. Some common answers that students typically give me are whether or not there's a load. So you could have a truck that has no load being carried versus a truck that has a really big load that it's carrying, like a trailer or something like that. That would affect the mileage. Another thing, it could be just the type of engine. Different types of engines burn fuel differently. So you might come up with some other ideas. I'd be interested to know what you think about that. So when you have a scatter plot and you're comparing two different variables and you see that there's a relationship, another piece of terminology that we would use is that there's a correlation. A correlation is a relationship between two variables. So if you see a graph that looks like this, we would call that a positive correlation. And if you see a relationship that looks like this, we call that a negative correlation. So positive correlation, the trend is positive. It increases from left to right. Negative, it decreases from left to right. So if we were asked to describe the relationship for a positive correlation, we would use words like if X increases, then Y increases. Or if it's a negative correlation, we would phrase it like if X increases, then Y decreases. So I just want you to be able to know what correlation means. Correlation just means there's a relationship between those two variables when you look at a scatter plot. I'd like you to take a minute and think about each of these different sets of variables. Would each have a positive correlation, negative correlation, or no relationship at all? So compare the amount of hours studied versus the test mark. So those are two different variables. Do you think there would be a positive correlation between the two, a negative correlation between the two, or no relationship at all? Go through each one. Think about whether you think there would be, or what kind of relationship there would be. Pause the video as you think about it, and then when you're ready, you can unpause, and I'll tell you what I think. Okay, so here's what I think about the first four. I'll get to the last one later. For the first one, hours studied and test mark. Well, remember, we're talking about in general. We're not talking about maybe the individual person that is the exception. And we're talking about what would it be for most. Because remember, the relationship is a general trend. So in general, as the number of hours that you study increases, does your test mark increase, decrease, or stay the same? Well, I would argue that as this increases, so does this. So I would say as the hours studied increases, the test mark increases. That's a positive correlation. Hours of TV watched versus hours of exercise. So let's think about it. If you're watching more TV, are you going to be exercising more, less, or not changed at all? Well, remember, it's most of the time. We're talking about in generalities, not your particular case. So in general, if you're watching more TV, you have less time to do exercise. So I would argue as the hours of TV increases, the hours of exercise decreases. That's a negative correlation. A person's height versus the sum of the digits in their phone number, there's obviously no relationship there. If you add up the numbers in your phone number, it has absolutely nothing to do with your height. There's no relationship there. We would see just a random scattering of points on a scatter plot. Income versus years of education. Typically, the more education you have, the higher paying job you can get. Now, of course, you're going to think of exceptions to this, but we're talking in general terms here. In general, this is a positive correlation. I just had to pause the video there because my baby was screaming, so I'm back now. Hopefully you don't hear him in the background anymore. Last one here, years worked at a company versus the number of days absent this year. Well, this one's kind of tricky because for a lot of companies, the longer you work somewhere, the more days you're allowed to take off. So you could say there's a positive correlation there, but also you could just start a job and then take days off. A lot of places the number of sick days or vacation days doesn't really change the longer you work there. So I think for this question, we would need to know more information in order to decide what kind of a relationship there would be. Now I'm just going to throw this in because we're talking about correlation. Correlation does not mean causation. This is a really important thing to understand. If you only remember one thing from this entire course, I would say this is probably the most important thing to remember. Correlation does not mean causation. Here's an example. There's a correlation between the amount of money from ice cream sales and the number of drowning deaths. You can look up the statistics. You can see as the number of drowning deaths increases, so does the number of ice cream sales. So does that mean that ice cream causes people to drown? Well, no, that's ridiculous. There is a correlation in the data. There's a positive correlation. However, correlation doesn't mean that one of these things affects the other directly. So for this particular example, there's obviously another thing that's causing the drownings. It's not the ice cream, but what do they have in common? Well, the summertime. In the summertime, ice cream sales tend to increase. So as temperature increases, so does ice cream sales. Also, as temperature increases, more people are swimming, so more people are drowning. So there's not a direct causation here. The more ice cream you eat doesn't mean you're more likely to drown. There's a missing link here. And so you have to be careful with that when you're shown graphs, when people are using statistics to make an argument. Be aware, just because there's a correlation between two things, it doesn't mean that one of them is causing the other. So again, if you remember one thing from this course, this is going to be the one thing that I hope you remember. Okay, last example here. If the independent variable is the amount of coffee consumed, give a dependent variable that would give a positive correlation, negative correlation, and no relationship at all. So let's start with a positive correlation. As the amount of coffee consumed increases, what would be something else that increases? Think about it. What about a negative correlation? As the amount of coffee consumed increases, what would decrease? Think about it. And what is something that has no relationship at all to the amount of coffee being consumed? So take a minute to think about it, come up with some ideas, and when you're done, unpause the video, come back, and I'll give some examples of things that I thought of. Okay, so here are some ideas I had. A positive correlation. So as the amount of coffee consumed increases, perhaps sales at Tim Hortons would also increase. That would be a positive correlation. Negative correlation, amount of sleep. You would expect as more coffee is consumed, the amount of sleep will decrease. And no relationship at all, shoe size. Okay, so the amount of coffee consumed, I would expect there to be no relationship with a person's shoe size. Okay, as far as practice questions go, these are what they are, and they're all on the questions document on the weekly checklist. So try them, and if you get stuck, reach out for help.